Hello guys and welcome back. So let's keep on building our game. So in this one, we're gonna really set up our movement now, right? We have the inputs hooked up with the functions, but those functions are not doing anything other than logging out, right? So let's go ahead and set up the movement. In the header file, I'm gonna create another attribute, and this time I'm gonna make it private, because making things private will prevent other things, right, other objects to access it. That actually reduces accident, right? You make something private, then you have the peace of mind that this thing will only be changed internally. So when there's a bug about this attribute somehow, like it's not giving the right number or something, you know that it has to be somewhere inside, right? It cannot be somewhere outside, right? So that way your code is easier to debug. I think that's the primary focus, right? You wanted to keep things intact, just like when you create a car, right? When you're building a car, you want to give the driver the wheel, right, the brake and the gas, and maybe the windshield brush, those kind of like controls, but you don't want to give them the control of, you know, the internal things, right? Like some certain part of the engine, how it works, or how certain part of the engine's stuff. You don't want the driver to touch those things, because those are something that could break if you don't do it correctly, right? So in other words, the public ones are something we call the interface of this object. That's where other object can interact with it, the interface. The private ones is the internal structure, the internal things that shouldn't be touched by the user or by any other objects, right? That way we can logically separate how to use this function to how the details of the function, how to use this object compared to how the details of the object should be or is implemented, right? It's a very important concept. So apparently the move direction is just internally for the snake hat, right? No one else can change it or should be changing it. So I'm gonna create that f vector move direction. Okay. Now in the move map, move down, move left, move right, which we could, let's see if we can also put them into the private, because I'm not sure if the banding will work, but let's see. Okay, so move up, move down, move left, move right, they're all in the private sector now, because no one have to know, right? So now in the CPP file, instead of doing that, we can say move direction will be equals to f vector. Moving up direction will be the axis. If you take a look at the, you know, you can see up is x, right? So back here to our code, we can say it's going to be 1, 0, 0. Okay, now moving down will be -1, so I'm going to replace that with -1. Now moving left will be let's see, moving left, it will be -y, right? So let's do that. -1 here on the y-axis, and moving right will be 1 here. Right, now we're changing a move direction now instead of printing things out. Okay. And then I want this thing to be moving or ticking every 0.25 seconds. I'm gonna actually do that. Primary actor tick dot tick interval. Interval will be equals to 0.25. So this will take or update, or this tick function will be called every 0.25 seconds. That way we're popping the snake to the next, to the next, to the next, right? Now while we're at it, I also need to know, like, for every 0.25 seconds, right? This will be called how much are we moving? Well, we know the direction. We also need to know how much we're moving towards that direction, right? So back here to the header file, I'm gonna create another variable called float move step, or step size. Move step size. And how much do we move per step? Distance wise, it's going to be a float number, which is a number that can have a decimal point and a fraction of a number. Move step size. Now back here to the CPP file, I can do that in the begin play. begin play is called when the game starts. I can populate that information here. So move step size will be equals to head mesh get static mesh get bounding box dot size get size. Okay, and then we're getting the x size. It doesn't matter which axis because it's a ball, right? It's the same on all dimensions. So we're just gonna go a little bit cheaper and just get the x-axis of the size, which size is three-dimensional f vector, right? We need to just get one of them. Bounding box is the bounds, right, of this entire mesh, right? That's basically what we're saying is that our move step will be one snake head ahead, right, to the next step. So now I know how much I want to move. I know the direction here by hooking up that with the inputs. So for every tick, we're just going to say add world offset. Add that much of an offset here, right? How much we're moving will be basically the move direction times move step size. Okay. It doesn't know what that is for some reason. Which shouldn't be. Add actor world offset. So we have to add actor world offset. That's the one. Yeah. Okay. So this will add that much of an offset. Again, this will be updated every 0.25 second. Right, a quarter of a second, our snake head will be moving towards the move direction, and it's gonna move the size of the head. So it's gonna jump one head ahead towards the move direction. Right. Save this, and then back here we're gonna compile. Now run it. You can see now when I hit those buttons, you can see the ball is start moving. You can see some weird like motion blur happening in there. We can fix that by going to project settings, and we can just search for motion blur and check that off. Okay, play that again. Right? Cool. That's the basic movement setup. Doesn't take us long, right? Just 7 minutes. So let's move on to the next video. I think we can set up we should be able to set up other stuff now, right? We have a moving head, and maybe we can start doing other things like the fruit or the tail. Okay, let's do that in the next video.